Hi friends, welcome to Curing Electronics. Today we are learning maximum power transfer theorem and this is the part 1. As usual, this is an introduction to maximum power transfer theorem as well as we'll solve one simple problem to understand the maximum power transfer theorem. So let's start. So today's topic is maximum power transfer theorem. Maximum power transfer theorem. Maximum power transfer theorem. What is the definition of maximum power transfer theorem? Maximum power is transferred from a source to load. Power is always transferred from source to load when the load resistance is equal to is equal is equal to the internal resistance of resistance of source, because all sources will have some resistance. So we can consider what we have a DC network. We have a DC source network, and we want to connect it to load. We want to connect it to load. We want to connect it to load. So these are our source output terminals. Here we are connecting the load. This is RL. This way I can take it as X and Y, these two output terminals of the source. Now, whenever we have a such kind of network and a load, we can replace this circuit, this entire part by, we can replace this network by a Thevenin circuit, that is VTH in series with RTH. So this DC network, whatever the DC network, source network, can be replaced with a Thevenin network VTH. Now we will connect the load. Now we can connect the load and vary the load and see when the maximum power transfer take place. When the maximum power transfer take place. Now if we see, now power delivered to load, power delivered to load, power has to be delivered to load only. Okay, so that is equal to, what is the power equation? P equal to V into I, or I square RL, because our load is RL, which means what is I here? from the previous, what is I here? VTH divided by RTH plus RL. This is our RL. This is the RL. So that is I square. I have to write what is I square. VTH by RTH plus RL whole square. Here also square multiplied by RL. So this is the power delivered to the load. This is the power delivered to the load. Now if you draw a, see now we'll plot, if you plot a load resistor versus power, we will get a plot like this. That is at this point, at this RL, power is transferred maximum. Okay, power is transferred maximum. This is the P max point. The P max point. See if we P max point. Okay, now we'll try to manipulate this equation. That is, if we try to simplify this, what we will get? P max, power delivered to the load, power, VTH square divided by, we are expanding the A plus B whole square, RTH square plus 2 RTH, R Thevenin and R load plus RL square multiplied by RL. We take it as, now this equation is divided by RL, numerator and denominator. Then what we'll get? We get VTH square divided by RTH square by RL plus 2 RTH plus 2 RTH plus RL. RL will get. This is the power delivered to the load, P delivered to the load. Now if you see at this point, see here at this part, if we draw a tangent here, the slope of the tangent equal to 0. So at this point, P max equal to 0. So this denominator of this equation, that is RTH square plus 2 RTH plus RL, if you differentiate with respect to at P max means this is equal to 0. If you differentiate this equal to RL, we will get what is the relation between RL and RTH. Now that is RTH square by RL plus 2 RTH plus RL equal to 0. We will differentiate with respect to d of RL, drl. So what is there? RTH square. This is the derivation for when maximum power is transferred. What is the relation between RTH and RL? At P max, the slope equal to 0. So 2 RTH plus RL. If you differentiate this, which is equal to what? RTH is a constant, RTH square constant. So minus RL square plus with respect to RTH differentiating with respect to RL equal to 0 plus 1 we will get. So now which gives now if we multiply minus RT plus RTH square divided by RL square equal to 1. Now RTH equal to RTH square equal to RL square. So we will get RTH equal to RL. We got at power maximum Pmax at Pmax RTH equal to RL. Now we got the relation. Now what we will do, we will go back to the what is the equation of power max. We have to find out. Now at when RTH equal to RL, maximum power is delivered to the load. So Pmax equal to whatever the Thevenin circuit we have drawn. That is what is the Thevenin circuit we have drawn? And that is a network, source network can be replaced with a Thevenin equivalent circuit. That is, this is RTH and this is the load we have varied. This is RL we have varied. Now we find out when RTH equal to RL, maximum power is transferred. Now what we will write the power maximum. Pmax that is equal to VTH divided by RTH plus RL. Instead of RL, what you will write? RL. First you will write RL whole square into multiplied by RL. Now this RL can be replaced with, now if you replaced with, so it is VTH square. RL equal to RTH. So 2 RTH whole square into this RL also we can replace with RTH, which comes to VTH square divided by 4 RTH square multiplied by RTH. So now we will get the equation for Pmax. Pmax, maximum power is transferred when maximum power is transferred, that is VTH square divided by RTH and RTH square cancels. 4 RTH. So this is the equation for maximum power transfer. This is the equation for maximum power transfer. And where and all this maximum power transfer theorem is utilized? Where and all this maximum power transfer theorem is utilized? This is utilized in communication systems. It is utilized in communication systems. Communication systems. In communication systems, we have to match the 50 ohm load with the source or 75 ohm load with the source, then only the maximum power transfer will take place. And one more point you note it, the maximum efficiency at Pmax equal to 50%. So at 50% only, but maximum efficiency of this efficiency we get when using power transfer theorem is 50%. Okay, so this also you should remember. Then one more thing, for power systems, we won't usually power systems not considered maximum power transfer theorem, MP, MPTT, maximum power transfer theorem, because in the power systems we will take care of the voltage drops, like that things, voltage drops and all. So the power transmission, we won't consider the maximum power transfer theorem usually, but in communication system it is must. And the equation for maximum power transfer theorem equal to P max, we will get when maximum power will be transferred, RL equal to RTH. And what is the power transferred? VTH square divided by 4 RTH. Now we will solve a simple problem with this, then you will get an idea about it. Question. We have a 120 volt, one resistor, one more resistor. It's a simple circuit, so to understand the theorem, this problem should be enough. And if you want to master it, please watch the second part. Second part will provide you more complications and more clarity on power transfer theorem in detail. This is 60 ohm. And friends, please subscribe the channel and share the video with your friends. I'll be updating many more videos, so it will be useful for you and your friends. So the load resistor he has given us. What is the load resistor? Load resistor, not varying load. It's a load resistor. A load resistor value equal to 10 ohm. Okay, he has not given the load resistor. We have to find. We have to draw the. Okay, so this is a question. Calculate the value of RL. RL we have to find out. For maximum power transfer. Power transfer. Okay, now. So first of all, we have to replace this circuit with Thevenin circuit. Then we will consider the load. Now if you replace this circuit, first we will find the open circuit voltage. Which open circuit voltage, once you open the load, what is the voltage here? That is equal to the VThevenin voltage. So now 120 volt is there, 120 volt. Then we are connecting one 40 ohm resistor, then 60 ohm resistor. Here one more resistor, 20 ohm. And this source is 120 volt plus and minus. This is 40 ohm resistor. And this is 60 ohm resistor. Now we have to find VOC. This is the open circuit voltage. Now how do you find the open circuit voltage? Here we see here we can apply here the whatever the voltage is here. If it is V1, the same voltage is there VOC, because this is not a closed, it's an open circuit. So whatever is the drop is here, we'll use the voltage divider rule, that is V1 which equal to VOC equal to 20 ohm divided by 40 plus 20, that is 60 multiplied by 120. 40 plus 20, 60 divided by 120. 0 0 2 times. So it equal to 40 volt. The open circuit voltage equal to 40 volt. Now what is RTH? RTH. RTH. Once RTH, how do you find out RTH? To find out RTH, we have to short the voltage source. Then we have 40 ohm, 60 ohm. No, here nothing is there, no? Hello, how do you do? It is little boring. I also got into it completely. Okay, to learn we have to go through this. So what are the values? What are the values? We have short circuited the voltage source. What is the current source? You'll open circuit it. What is the is 40 ohm and this is 20 ohm and this is 60 ohm. Now what is the resistance? Total resistance 40 ohm in parallel with 20 ohm will give you 40 multiplied by 20 divided by 60. What it is? 3 1. 40 by 3. 40 divided by 3. What it gives? 40 divided by 3 gives 13.3 ohms, which is equal to 13.3. Plus what is in series? The 60 ohm is in series. So we will get total 73.3 ohm. That is RTH. We got the RTH also. Now we got the RTH. RTH also we got. So now we know when R will equal to, so what now we'll draw the equivalent circuit. Open circuit voltage, that is 40 volt plus minus. Then we have a resistor 73.3 ohm. Now maximum power is transferred when RL equal to 73.3 ohm. P max happens. P max. What happens? Maximum power is transferred. So how do you know now? What is the value of P max? P max equal to what is the equation we have derived? What is the equation? That is VTH square, open circuit voltage square divided by 4 times R Thevenin. That is equal to 40 square divided by 4 times 73.3 ohm. It comes to what? It comes to 5.45 watt. I used calculator. You can solve it yourself. So friends, I hope you understood what is power transfer theorem. If you have any doubt, please feel free to ask. Please feel free to ask. So maximum power is transferred when load resistance is equal to the source resistance. And thanks for watching. Please share the video with your friends. Please give a like button if you like the video. If you don't like the video, please don't do anything. Please comment it. I will improve it. Thank you. Thank you for watching.